Good morning everybody. Today we shall start solving some of the numerical problems pertaining to centroid. Basically, prior to the startup of the problems, we are supposed to know some of the important things related with this centroid. Say for example, if we have been given any of the composite section, means to say if the section is combined with too many predefined geometric figures, then we have some procedure to solve that particular problem. We shall get to know how do we solve that type of problems. Here it goes. Locate the centroid of area shown in the figure below. So here is a composite area for which we are supposed to locate the centroid. So first of all, prior to the startup, we shall understand the general procedure to get the centroid. Firstly, we are supposed to mark the coordinate axis. So here would be the coordinate axis. This would be our x-axis. Here is the y-axis. So these two are the coordinate axis. So now the next thing is that after marking the coordinate axis, that is x and y, next thing is that since we know it is a composite area, we are supposed to divide that composite area into component areas, means to say into different geometric figures. As we can see from this diagram, here we have two different geometric figures. It means to tell here I have a rectangle and one more rectangle is being here. Together we are supposed to locate the centroid. So now we shall divide the composite area into individual components. So that is what is said here. This would be one component and here is the other component. Next is that we are supposed to identify the centroid for individual components. So let us just identify the centroid. Before this, very important thing is that we'll have to identify the axis of symmetry. So here is the axis of symmetry. So now for our understanding, it is very clear that a centroid for both the sections lies on the axis of symmetry. So axis of symmetry lies on y-axis here. means to tell we can get the mirror image of one another provided the axis of symmetry is on y-axis. But can we write the axis of symmetry in x-axis? No, because we don't get the mirror image if we just fold containing the x-axis as the axis of symmetry. So now, after marking the axis of symmetry, next thing is that we are supposed to calculate areas of individual components. So now, the area of the first component, it is 60 into 10. So we get 600 millimeter square. Next, area of the second component. So again it is 10 by 60. Base into depth. It is 600 millimeter square. Next thing is that we are supposed to calculate the coordinates of individual components. So what is the coordinate that we are supposed to find out individually? It is y1 and y2. So now y1 is the coordinate of the first component, y2 is the coordinate of the second component. Why not we are supposed to find out x1 and x2? Since the axis of symmetry lies on y-axis, x bar is 30 mm. So now finding out y1 and y2. We shall mark y1 now. This is y1. So the distance is from the x-axis up till the centroid of the first section. That is represented as y1. Next, the centroid of the second section. So the distance from the x-axis up till the centroid of the second section is represented as y2. So now we shall just find out what is y1. So y1 is from x-axis till the centroid of the first section. So it is 60 plus centroid of the first section is as such. So it is 10 by 2. Therefore, it is 65 millimeter. Next, the centroid of the second section. So it is 60 divided by 2. We get 30 mm. So we have a y1 and y2 value now. So now in order to calculate the centroid of the whole composite area, we are supposed to follow this expression, which goes as such: a1 y1 into 8 plus a2 y2 divided by a1 plus a2. As we have two sections, we are writing it as a1 y1 plus a2 y2 divided by a1 plus a2. Now substituting the values that we have written here. So a1 is 600 into y1 is 65 plus a2 is 600 again into y2 is 30 divided by a1 is 600 plus a2 is 600. Upon calculating, we get the value as 47.5 mm. So y bar is 47.5 mm. Together we can write the centroid for this particular composite area as the values of x bar and y bar as 30 and 47.5 mm. This is how it goes. Moving on to the second problem. So now we can just see here we have a composite section wherein we have three individual geometric figures, that is one semicircle, two rectangle and three triangle. So now our first step is to mark the coordinate axis. It is x axis. Here would be the y axis. The reference center is O. The next thing is that we are supposed to check for the axis of symmetry. So where can I write the axis of symmetry? Can I write it with respect to y axis? Definitely no, because I don't get the mirror image if I write the axis of symmetry on y axis. So the axis of symmetry is on the x axis. So it means to tell that we have y bar as 20 mm. So now the next thing is that we are dividing the composite area into semicircle, rectangle and triangle. So in order to calculate x bar, we are supposed to find out the values of individual components. So now as we have three different geometric figures, it is a1x1 plus a2x2 plus a3x3 by a1 plus a2 plus a3. So now we are supposed to find out all these areas individually. So what is the area of the first section? Since it is a semicircle, it is pi r square by 2. So radius is given as 20. So it is pi r square by 2. The value would come around 628.32 millimeter square. Next, area of the second section, B into D. So B is 60 mm and this is 20 plus 20, that is 40 mm. So here we have 240 millimeter square. Next is A3. So here is a symmetric triangle. It is half into base is 20 plus 20 is 40 into height of the triangle is given as 30. So upon simplification we get 600 millimeter square. So now we have the values of A1, A2 and A3. Next is that we are supposed to find out the values of x1, x2 and x3. So let's just see the values of x1, x2 and x3. We shall mark the centroids first. This is the centroid of the first section. So means to tell we are considering the distance taking y as the reference axis. So all we want is from y till this centroid point. So this is the value of x1. We can just remember the derivation of a semicircle which goes as such, means the centroid will be here. So the distance from the base means to tell the centroid lies at a distance of 4r by 3 pi from the base. But here we have the distance to be calculated from this end. So it is the value of 20, that is radius, minus 4r by 3 pi. So we get the value around 11.51 millimeter. So this value is 11.51 millimeter. So now moving on to the centroid of the second section. So again considering y as the reference axis. So the measurement is from here to this point, means the centroid of the rectangle. So now what is this distance? It is 20 plus centroid of a rectangle 60 by 2. So this is 50 mm. Next thing is that the centroid of the third section. So here is the distance to be considered, means this is x3. So now this is 20 plus this distance is 60 plus, we can just see if it is a symmetric triangle, the centroid from the base is at a distance of h by 3, right? So here is our h by 3. What is h here? It is 30. 30 by 3. So now it is 95 mm. So now we are supposed to substitute all these values in this expression, and upon substitution of these values individually in this expression, we get So now the value of x3 is 90 mm. So now upon substitution of all these values here in this expression, we get the value of x bar as 49.55 mm. So now the value of y is 20 mm. Moving on to the next problem. The next problem is to locate the centroid of the area shown below. So here is the L section. We can just observe from this diagram that we don't have the axis of symmetry either in x-axis or in the y-axis. Means to tell, we don't get the mirror image if we write the axis of symmetry on x-axis nor on the y-axis. Means to tell, we are supposed to find out both x bar and y bar for this particular problem. So here we have two geometric figures, that is a one rectangle, other rectangle is here. So now we can just mark the first rectangle as such. In order to find out x bar and y bar, we are supposed to find out a1 x1 plus a2 x2 divided by a1 plus a2. Similarly, for y bar, we are supposed to find out a1 y1 and a2 y2 divided by a1 plus a2. So now we shall find out all the requirements individually. What about the area of the first section? It is 10 by 60. So it is 10 into 60. So here we get 600 millimeter square. Next, the area of the second section. So here we have to be careful. It is 50 by 10 mm. 50 by 10. So we get 500 millimeter square. So after finding out the area for individual components, we are supposed to find out x1 and x2 means to tell the x components of the individual sections. So x1. So in order to find out the values of x, that is x1 and x2, we are supposed to consider y as the reference axis. So here the y is the reference axis. So now marking the centroid for the first section. So here is the value of x1. So now, this value is 10 mm, right? We can just see here. So centroid of this section is 10 by 2. So we get 5 mm. Next, locating the centroid of the second section. So taking y as the reference, from y till this point is x2. So now what is this value? It is 10 plus centroid of this section, it is 50 by 2. So we get 35 millimeter. We can just observe this distance is 50. So centroid of this is 50 by 2. Next, moving on to the value of y1 and y2. So now we are supposed to consider x-axis as the reference. So this is the x-axis. So we shall just locate the centroid with respect to x-axis. So this is the first section. So here is the value y1. So y1 is from here to here. Means you can just observe it here. This value is 10 plus the centroid of this section. So the centroid of this section is So now we are supposed to find out the values of y1 and y2. So we mark the value y1 here, means to tell the centroid of this portion. So here it is 60 by 2. So we get 30 mm. Next is the centroid of this section. This is the y2. So the centroid of this section is 10 by 2. We get 5 mm. So now upon substituting all these values here, we get the value of x bar and y bar. So now upon substituting, we get x bar as 18.64 millimeter and y bar as 18.64 millimeter. So here is the centroid for this component area. We can just observe moving on to the next problem. here it goes. So now we can just see that we have 3 geometric figures here, of which we can just see that we have 2 shaded geometric figures. So now marking individually so now we shall just see, here is a triangle, a rectangle and a semicircle. So we don't have the axis of symmetry here, means we are supposed to find out both x bar and y bar. Now writing the reference center, here is the coordinate axis, x axis and y axis. So we are finding out x bar as a1 x1 plus a2 x2. The very important thing we have to note here is that the third section, that is the semicircle, is to be considered as negative because this portion is to be scooped out from the component area. This portion is to be scooped out from the composite area. So that particular section is taken as negative. Similarly, the third section, that is the area of the third section, is prefixed with a negative sign. So now again, to find out y bar, we are supposed to consider the third section as negative. Now we shall find out all the 3 sections individually. Now we shall find out all the required components now. First of all, area of the first section. So the first section is a triangle, a right angled triangle. So here it is half into base is 3 into height is 4. So we get 6 centimeters square. Now area of the second section. So here it is B into D. So it is 4 by 4. 4 by 4. We get 16 centimeters square. Next is area of the third section, that is a semicircle. The radius is 2 centimeter. Therefore, it is pi r square by 2. we get 6.28 centimeter square. So now we shall find out x1, x2 and x3. First of all, to find out the values, that is the components related with x-axis, that is x1, x2 and x3, we are considering y-axis as the reference. So we shall mark the centroid for all the components. Here is the centroid. So the value of x1 is to be considered as such. So we can just observe, since it is a right angled triangle, we can just see here we have this value as b by 3 and the remaining value to be considered as 2b by 3. Likewise, here the value is h by 3 and the other end will be 2h by 3. So now, to find out the value of x1, we just have to consider the distance from here to this point. So this point is 2h by 3. 2 into h by 3, where the value of h here is 4 centimeter. So it is 2 into 4 by 3. We get around 2.667 centimeter. So now moving on to the second geometric figure. So here would be the centroid. The distance to be considered as x2 is marked here. So the centroid of this geometric figure is 4 by 2. Lies at a distance of 2 centimeter. So the value of x2 is here. Next, the value of x3. We are marking the value of x3 here. So this is to be considered as x3. So it is nothing but the radius. So it is 2 centimeter. Next, moving on to y1, y2 and y3. We'll just see how we are locating y1, y2 and y3. So here is the centroid marked. So the distance of y1 is here. That is taking x-axis as the reference. So what is this value? It is 4 centimeter plus this value. It is b by 3. So it is 3 by 3. Therefore it is 5 centimeter. Next, here is the point. So y2 is marked here, means the centroid of the second section is 7 by 2. Therefore it is 3.5 centimeter. Next, the centroid of the second section. So it is 4 by 2, 2 centimeter. Lastly, the centroid of the third section. So we can just see here, it is a semicircle. So where does the centroid lie for a semicircle from the base? It lies at a distance of 4r by 3 pi. So now 4r is 2 centimeter by 3 pi. we get the value as 0.848 centimeter. So now, upon substituting these values in the expression of x bar and y bar, we get the value of x bar as 2.255 centimeter and the value of y bar as 3.605 centimeter. So the coordinates of the centroid for this component area, for this composite area, is 2.255 and 3.605 centimeter. We shall move on to the next problem. The next problem, locate the centroid of built-up section shown here. So from this diagram we can just see Where is the axis of symmetry? It lies on y axis. So since axis of symmetry lies on y axis, we have the value of x bar as 300 mm. So we are supposed to find out y bar here. So since we have 1, 2, 3 and 4 rectangles, we are supposed to find out a1 y1 plus a2 y2 plus a3 y3 plus a4 into y4 divided by a1 plus a2 plus a3 and a4. So now we shall mark the coordinate axis first. So here is the coordinate axis x and y. We'll mark the individual components 1, 2, 3 and 4. So in order to find out y1, y2, y3 and y4, we consider x as the reference axis. So the centroid lies on y axis for all the 4 components, that is individual components. So where does the centroid lie for the first component? I just show it here. So considering x as the reference axis, this is the value of y1. So how do we consider y1? It is from x-axis till the centroid of the first section. So counting from here, it is 100. I'll just write the value of y1, 100 plus, what is this value? 800 plus 100 again plus the centroid of the first section. So it is 100 by 2. So we get the value as So now we shall find out the areas of all the 4 sections individually. First of all, area of the first section, second, area of the third section and the fourth section. So area of the first section is 300 plus 300, 600 into 100. It is 600 into 100. So we get the area of the first section. Next, area of the second section. It is 250 plus 250 into 100. So it is 500 into 100 millimeter square. Area of the third section. So again here it is 100 by 800. 100 by 800. We get, lastly, area of the fourth section is 250 plus 250 by 100. So it is 500 by 100 millimeter square. So now we have the values of the areas. Next, we shall find out the values of y1, y2, y3 and y4. So now, where are we supposed to mark the value of y1? Centroid of the first section is here. So, we'll mark the value of y1 right from the x-axis till the centroid of the first section. So, we are supposed to consider 100 plus 800 plus 100 plus 100 by 2. We get the value of 1050 millimeter. Next, the second section, this is the centroidal point, marking the value of y2 here. Again it is 100 plus 800 plus 100 by 2. 100 plus 800 plus 100 by 2. We get 950 millimeter. Next, marking the centroid of the third geometric figure. This is y3. Therefore, it is 100 plus 800 by 2. So, it is 500 millimeter. Lastly, the centroid of the fourth section, we are getting 100 by 2 as 50 millimeter. So now we are supposed to substitute the values of x1. We are supposed to substitute the values of a1, a2, a3, a4 and y1, y2, y3, y4 in the expression that is to be used to find out the value of y bar, and upon substitution we get y bar as 637.5 millimeter. So now the value of x bar is 300 mm and the value of y bar is 637.5 millimeter. This is how it goes.